Hello, welcome to Sidtronics. In this video, we are going to look at different types of variable resistors. We will also understand how they work by the end of this video. But, before that, let's first understand what are variable resistors. Variable resistors are electrical components whose electrical resistance can be adjusted by either mechanically, digitally, or by other factors such as light and heat. So let's move on to our first type. Number 1, potentiometers. Potentiometers are a type of variable resistors whose resistance can be adjusted by turning this knob around. Potentiometers has 3 pins. These 2 pins are end pins, and this pin is a wiper pin. When knob of potentiometer is turned around, resistance between wiper pin and end pins changes accordingly. Let's see how they work using an animation. Before animation, let's have a look at its parts. Potentiometer has a resistive material of certain resistance. Ends of this material are connected to the end pins. Here, A and C are end pins. Wiper pin is connected to a sliding contact, which is depicted by this arrow. For better understanding, let's switch to a simplified diagram. Suppose this is resistive material. So this are end pins of potentiometer. And wiper pin is depicted by an arrow above it. When we turn the knob of potentiometer, the wiper of the potentiometer slides on the resistive material. This way you can change resistance between wiper and end pin. Resistance of this resistive material depends on the potentiometer you are using. For example, if you have a 100 kilo-ohm potentiometer, you can adjust the resistance from few ohms to 100 kilo-ohms. This component can be useful in circuits where you need to adjust resistance between 2 terminals without even changing the component. Just how I did in my 555IC monostable mode tutorial. Resistance between wiper pin and one end pin, plus resistance between wiper pin and other end pin is equal to rating of your potentiometer. For example, if my potentiometer is of 100 kilo-ohm, and resistance between wiper pin and one end pin is 10 kilo-ohm, then resistance between wiper pin and other end pin will be 100 kilo-ohm minus 10 kilo-ohm, which is 90 kilo-ohm. So by using only 2 pins of potentiometer, you can easily change the resistance between 2 terminals without changing the component. You can also use potentiometer as adjustable voltage divider by connecting its end pins to power supply. Let's leave that topic for another video. Potentiometers come in different sizes, shapes, but they all work on same principle. This is a symbol for potentiometer, which is used in circuit diagrams. Okay, now let's move to our next type of variable resistor. Number 2, LDR. LDR stands for light-dependent resistor. As name describes, resistance of this component depends on light intensity available on its surface area. When there is no light at all, the resistance of this component can go as high as several mega-ohms. While in light its resistance can drop to few hundred ohms. Its resistance drops with increasing incident light intensity. In other words, it exhibits photoconductivity. Due to this reason, they are also called light-decreasing resistance. It can be useful in circuits where you need to sense the light. For example, in this circuit, LED turns on when there is low ambient light, and LED goes off when there is enough ambient light present. This is symbol for LDR, which is used in circuit diagrams. Okay, now let's move to our next type of variable resistor. Number 3, thermistor. Thermistor is a passive electronic component whose resistance depends on ambient temperature. There are 2 types of thermistors, NTC type and PTC type. Let's first have a look at NTC type. Resistance of NTC thermistor is at maximum at low ambient temperature. For example, if this thermistor is of 10 kilo-ohm, then at low ambient temperature, the resistance of this thermistor would be around 10 kilo-ohm. Resistance of this thermistor will drop with increasing ambient temperature. This property makes them extremely useful in various electronic projects, such as fire, alarm, DIY thermometer, etc. Now, let's have a look at PTC type thermistor. In case of PTC thermistor, its resistance increases with rise in ambient temperature. In other words, its resistance is directly proportional to the ambient temperature. Now, let's take a look at resistance temperature graph of these thermistors. This is a graph of PTC thermistor, and this is of NTC thermistor. Thermistors can be useful to create some simple circuits, as shown in the video. These are symbols of thermistors, which are used in circuit diagrams. So that's all for today's video. I hope you learned something new. If you want more such videos, consider subscribing.